Micro-pitting typically occurs in gears at a contact pressure of between 0.5 and 1.5 gigapascals and at slide roll ratios of between 10 and 20%. Conventional micro-pitting rigs typically have a rod sample loaded between three support rollers, which are driven at different speeds to generate constant slip. Such rigs are usually expensive and require one test roller and three driving rollers per test. By comparison, micro-pitting tooling on a reciprocating rig can use simple, inexpensive samples and provide continuously varying slide roll ratios, as happens in actual gear contacts. This current development project is a simplification of various slide roll adapters available on our standard TU77 reciprocating tribometer. In this design, a pair of 20mm diameter rod samples are loaded against plate samples mounted on either side of a reciprocating assembly. Carriers on top of each rod sample provide locations at varying pitch circle diameters for driving pins. These engage with slots on a driving plate on the reciprocating assembly. For a driving pin located at 20mm pitch circle diameter, the motion of the roller at mid-stroke will be pure rolling, with increasing slide roll ratio towards the end of the stroke. The motion is thus similar to a gear tooth contact rolling and sliding about the pitch point. By altering the driving pin pitch circle diameter, the range of slide roll ratios can be varied. Whereas low slide roll ratios are intended for generating micro-pitting, at high slide roll ratios it may be possible to simulate gear scuffing. The maximum reciprocating stroke for the current design is 12mm and the minimum stroke is 2mm. Increasing the driving pin pitch circle diameter and reducing the stroke to, say, 2mm generates a contact with microslip. Our initial tests indicate that this has the potential to model the kind of fretting observed in bearings. The load capacity of the current machine is 5 kilonewtons. It may be possible in due course to scale up the concept to allow tests to be run at much higher loads on larger, slower moving bearing rollers. If you would like to be kept up to date with ongoing developments, please let us know.